this is Rajesh. Welcome to our class. This is our third lecture of the chapter matrices. Now in this lecture we will see what is the inverse of a matrix and how we can obtain the inverse of matrix. So inverse of a matrix. Now if A and B are two square matrices of the same order such that AB equal to BA equal to I, then B is called the inverse matrix of A and is denoted by A inverse. So A and B should be of the same order and their product should give us I. I, that means identity matrix or unity matrix. Then in that case I will say that B is the inverse of A and I will write B as A inverse. Here A is said to be invertible. That means we can find inverse of A. Inverse of matrix can be obtained by using elementary row transformations or column transformations. Now inverse of square matrix if exist is unique. Now what it means? That it is not necessary that you get the inverse of a square matrix. It is possible or it may not be possible. Now if it is possible, then it is unique. That means each one of you will get the same answer. Now a rectangular matrix does not possess inverse matrix. We cannot find the inverse of a rectangular matrix. If B is inverse of A, then A is also inverse of B, right? And finally AB the whole inverse is equals to B inverse into A inverse. So these are few properties of inverse of a matrix. Now there are few steps involved while finding the inverse of matrix. We can find inverse of matrix in two different ways, either by elementary transformation or by adjoint method. Now the adjoint method we will see in our next chapter, which is determinant. In this particular chapter we will find the inverse of matrix by elementary transformation. Now in the previous lecture we have discussed what is the elementary transformation. You can go through the previous lecture and find out what is there in elementary transformations. Two types of transformations are there, row transformation and column transformation. We will see each one of them by example. Now what are the different steps involved? First step is, suppose we have a given matrix A. Then first we will write A equal to I into A. This is for applying the row operations only. So there are two ways, as I said, that either row operation or column operation. Now in one problem you can apply either all row operations or all column operation. When we are applying all row operation, in that case I have to write A equal to I into A. When I apply the column operations, I will write A equal to A into I. This is very important. Mostly you are going to solve the problems by row transformations. So remember this, A equal to I into A. Now here I is identity matrix of the same order as that of the A. So whatever will be the order of A, like 3 by 3 or 2 by 2 or 4 by 4, generally we will not get any problem of 4 by 4. So either 2 by 2 or 3 by 3. So our I will also be of that order. Now second step is, we will apply various elementary transformations, either row or column, right, on the left hand side, and apply the same operation on I on the right hand side, so that LHS, that is left hand side, will reduce to I. Now this A equal to IA, what I will do, I will apply row transformations and I will bring this A to I. whatever row transformations I am applying to the A, the same row transformations I will apply to this I. So what happened after doing these transformations, I will get I in place of A, and my I will change to some other matrix B. So I will get I equal to B into A. This is when we are applying the row transformations. And if we are applying the column transformations, I will get I equal to A into B. Now this matrix B is inverse of A by definitions. Hence, A inverse is obtained, right? The algorithm to obtain A inverse by row transformations is now what we have discussed here, that if we wanted to write in shorter form, what we will say, that first I will write A equal to IA, then I will perform a sequence of elementary row operations successively on A on the left hand side and the prefactor I on the RHS. Thus, I will obtain I equal to BA. And finally, I will write A inverse equal to B. Yes, so this is how we will find the A inverse. Now, in the step number 2, right, we may use the following steps to perform step number 2 above for a square matrix of order 3. Actually, here there is some printing mistake. It should be of order 3. So, step number 2 is what? Step number 2 is applying the various elementary transformations, right? So, how we apply various elementary transformations to bring A to I. Now, it is not necessary that you follow these steps as it is. You can choose any way, whatever you like. But if you follow the problem in this sequential manner, stepwise manner, then you will get the answer. I can say that easily, right? So your first step will be introduce unity at the intersection of first row and first column, either by interchanging two rows or by adding a constant multiple of element of some other row to the first row. Now, as we solve the problem after these steps, you will understand these steps in a more clear way. Now, what in the first step I am saying? I am saying that your A11, that is first element of your matrix, should be 1. So, how we can get that 1? Either we interchange any two row or we add or subtract some multiple of any other row to this first row, right? Now second step is, after introducing this 1 1, that is A11 place as 0 as 1 unity, we will make all other elements in that column as 0. So we will introduce 0 at all other places in the first column. So this is our second step. First step is that we make A11 1 and then A21, A31, etc. as 0, right? Now in the third step, we make second row and second column element, that is A22 as 1. Now to make A22 as 1, we will either use second row or third row. We will not touch the first row. Okay, this is important, right? Because if we touch the first row, then the zeros which I have already made in the first column, they will disturb. We will get some other numbers, okay, at those places. So after introducing A22 as 1, what we will do? We will make all other element in that second column as 0 by some transformations. Now after that, A33, that is the element in the third row and third column, we will make that as unity, and all other elements in that particular column, that is third column, as 0 with the help of this third row. Now you kindly note that in this second step, when we make other element 0 in the first column, we are going to use the first row. Similarly, in the fourth step, okay, to make all other elements 0 in the second column, we are going to use the second row. And finally, to make all other elements 0 in the third column, we are going to use the third row. In the same way, we can do the column transformations also. Yes? Now, if after applying one or more elementary row operations on A, that is IA, we obtain all zeros in one or more row of a matrix on the left hand side, then we say that A inverse does not exist. Now my A inverse does not exist if any row is 0. Yes? Okay. Now elementary operations, what we have discussed in our last class, I have present the same here for your reference. Now go through these elementary operations, what we can apply, okay, to make the matrix A as unit matrix. Now we will solve one problem to make this clear, right? So first I will do the problem using the row transformations, and then I will do the same problem using the column transformations. I recommend that you take your notebook, pen and solve simultaneously while you are going through this video. Yes? So our first step is, I will write A is equals to IA. This is, I am applying the row transformations. Yes? So my A is what? This matrix 0, 1, 2, 1, 2, 3 and 3, 1, 1. And here I is what? Identity matrix of the same order. So it is 1, 0, 0, 0, 1, 0 and 0, 0, 1 into A. Now next I will interchange R1 with R2. Why? Because I have to make this 0 as 1. Right? So what I can do? I can either interchange, or there is one more way, that I will add this second row to this first row. Here I have applied the interchanging of row R1 with row R2. So if I interchange, what I will get? In this first row I will get 1, 2, 3, and in the second row I will get 0, 1, 2, right? Now what operation I applied here? This third row remain as it is. What operation I applied here? The same operation I am going to apply on this I. So here you can see that I have interchanged this second row and first row, right? Now what I have to do? I have to make this as 0, so it is already 0. Next I have to make this 3 as 0. Now to make this 3 as 0, which row I am going to use? I am going to use this first row. Okay, so this is 3 and this is 1. So what I should do? I should multiply this row 1 by 3, right? And subtract this row from this row, right now? So my operation will be, elementary operation will be, on R3, what I will do? I will subtract 3 times R1, right? So corresponding elements, like what I am going to do is, I will subtract 3 from 3, I will get 0. Then I will subtract 3 times 2, which is 6, from 1, so I will get minus 5. And 3 times, that is 9, from 1 I will get minus 8. And on the right hand side, in the same way, 0 minus 0, so I will get 0. Here 0 minus 3, so I will get minus 3. And here 1 minus 3 times 0, so it is 1 only, so I will get 1 only. Now once I have done this, next what I have to do? I have to make this A22 as 1. So it is already 1. So I will not disturb here. Now applying on R1 minus 2 times R2. So what I am doing? I am making this as 0 and this as 0. Yes? So apply. 2 minus 2, 0. This 1 minus 0, so it is going to be 1 only. And 3 minus 4, because 2 times of this row, so 3 minus 4 is minus 1. The same thing I have done here. I have subtracted 2 times R2 from this R1. So 0 minus 2, it is minus 2, 1 minus 2 times 0, so 1 minus 0 is 0, it is 0, right? Now this minus 5 I have to make 0. So what I will do? On R3 I will say that R3 plus 5 times R2. So on R3 I will say that R3 plus 5 times R2. So what do you get? You get this matrix, and the same operation you will perform on this I, so you will get this, right? Now next I have to make this 2 as 1. Now there is no other row below this. So what we will do? We will divide this second row throughout by 2. This third row by 2. So here I will divide this whole row by 2. Now as I divide by 2, on the right hand side these numbers will become a fraction number. So here problem will become little difficult, as now it involves the calculation of fraction numbers. Yes. Now after this is now 1. So what I have to do? I have to make this minus 1 as 0 and this 2 is 0. So what we will do? On this R1 we will add this R3, and this on this R2 we will subtract 2 times this R3. So let us do that thing. On R1 we will add R3, so we will get this matrix, and on R2 we will subtract 2 times R3, so we will get what we will get? We will get this matrix. Now on left hand side you will see that we have obtained a unit matrix. So this is I, this will be considered as B and A, and this B is what? A inverse. So what I will say? I will say that A inverse is this matrix. Hope it is clear to you all that how we have solved the problems using the elementary row operations. Now let us see how we will solve the same problem using the elementary column operation. Yes, so again I have taken the same problem. Now here I am writing A is equals to A into I. So please A equal to A into I and A equal to I into A. They are two different things, and how you have to use. So here whenever you are applying the column operation, your unit matrix should always be on right hand side. Now this is my given matrix. Here again what I am doing, I am interchanging this C1 and C2. So I got this matrix. Now next what we will do, I have to make this 2 as 0. So I will subtract 2 times of this C1. So I will make this as 0. So I will obtain this matrix. Now I have to make this 1. So it is already 1. So I will not do anything. Now this 2 I have to make 0. So I will subtract 2 times of this column. So C1 minus 2 times C2, and I will get this matrix. Similarly, this, to make this element as 0, I have to add C2. So what I will do? On C3 I will say that C3 plus C2. Now next this 2 I have to make 1. So again there is no choice, but I have to divide this whole column by 2. So I will divide by 2 and I will get this matrix. Now minus 5 and 3, this I have to make 0. So I will add 5 times this C3, and in this C2 I will subtract 3 times of this C3. So let us do that. Okay, so I will obtain this matrix, then I will subtract 3 times to make this as 0. I will get this matrix. Now you will obtain a unit matrix on the left hand side, and your right hand side is A into B, I will say that, and this B is what? B is A inverse. So thus my A inverse is this matrix: 1 by 2 minus 1 by 2, 1 by 2 minus 4, 3 minus 1, 5 by 2 minus 3 by 2, 1 by 2. I recommend that in your textbook there are a lot of problems involving these elementary operations. Please solve at least 4 to 5 problems so that you are comfortable with solving these kind of problems. Yes. So in this class we will see inverse. We have seen the inverse and how we can find the inverse of a matrix. In the next class we will see some theorems and any miscellaneous item if remaining in this particular chapter. Okay. Yes. So thank you.